Assalamualaikum and greetings Abid to panels and viewers. Today I'm going to present about my final year project 1 project proposal. The project title is Low Velocity Impact Performance of Reinforced Concrete Slabs. Firstly, I will introduce myself first. My name is Muhammad Aswad Bin Mahazir. My student ID is 2018654222. My supervisor is Dr. Muhammad AZIMIN bin GHANI. The content of this presentation is introduction, literature review, problem statements, objective, scope of study, limitation, methodology, expected result, and research plan. For the first one is introduction. Reinforced concrete structures may be exposed to low velocity collisions during the course of their service life. Common possibilities include debris carried in by a wave or flood, falling objects throughout an earthquake, automobile collision, and so forth. The impact load is described as the application of a short duration, higher pressure on reinforced concrete, producing in a high strain rate, significant initial force and stress wave, leading in a dynamic structural response that varies from static structural behavior. Hence, it is very important to understand the behavior of the reinforced concrete structures to enhance the capability of the structure's component. The compressive strength of concrete is rather strong, while the tensile strength is substantially lower. As a result, even when compressed, concrete will almost always break owing to tensile stresses if they are not adjusted. As a consequence, structural components that are subjected to tensile force must be reinforced with increased tensile strength in tension. Concrete's elasticity maintained virtually constant at low strains, but when cracks form, it begins to diminish. Because concrete does have a low coefficient of thermal expansion, it shrinks as it ages. Due to shrinking and strain, all concrete construction will fracture to some extent. Concrete that has been exposed to long-term stresses is susceptible to creep. For concrete, impact loading causes a strain rate effect on strength, stiffness, ductility, and fracture energy. In addition, inertia is triggered, affecting the resistance and fracture mode of structural concrete. The impact of inertial force on dynamic ultimate strength is still included of the constitutive root in most macroscopic models, now utilized in engineering applications rather than developing automatically from dynamic analysis. Next, we go to literature review. For the first one is reinforced concrete. When compact, concrete has a relatively high compressive strength but a much lower tensile strength. It is susceptible to cracking when pushed apart and also vulnerable to breaking when pulled apart. When creating concrete, the proportion of aggregate cement is routinely changed and the tensile strength is improved by additive, often still to make reinforced concrete. In other methods, concrete is made up of sand, ballast, cement, and water. The modulus of elasticity of concrete is a result of the aggregate and cement matrix modulus of elasticity, as well as their respective proportions. At low stress levels, the compressive strength of the concrete stays virtually constant, but when fatigue fractures form, it starts to drop. The elastic modulus of the hardened paste could vary from 10 to 30 gigapascal, with aggregates ranging from 45 to 85 gigapascal. Concrete compound then has a compressive strength of 30 to 50 gigapascal. Next, we go to the impactor. Based on the research that I found, the 15 slab samples were classified into 3 types based on the shape of the impactor's nose and the diameter of the impactors. As you can see in the slide, this is the example of the impactor. The first one is 10H, as you can see here. 10H stands for 10 centimeter diameter of the hemispherical nose, and then the second one is 10F. It stands for 10 centimeter diameter of the flat nose, and then the last one is 20F. stands for 20 centimeter diameter of flat nose. Then we go to finite element analysis. Finite element analysis is a concept established by the finite element theory (FEM), which was first published in the 1940s in conjunction with a series of research articles. The numerical technique is based on the fact that it is one of the techniques for solving partial differential equations and partitioning one huge body into many smaller varieties of body, each with its own significant boundary. Next slide. Next one is problem statements. To determine the effects of impact energy, which is specific more to low velocity impact energy, affected area diameter, and impactor nose shape on reinforced concrete slab, damage of reinforced concrete structural elements. Next, we go to objective. First one is to determine the performance of RC slabs under low velocity impact. Next one is to study the impact energy of various type impactor nose on RC slab. The last one is to investigate the slab damage of the reinforced concrete. Then we go to the scope of study and limitation of study. The purpose of this project was to investigate the study about behavior of reinforced concrete slabs due to the low impact. The reinforced concrete investigation was primarily focused on damaged slabs under low velocity impact. The design will then be identified using Abacus software. There are two parameters that to be focused on, analyze and evaluate, which are firstly the diameter of the impactor's nose, and second is the speed of the impactor to hit the reinforced concrete slabs. This study comes to the limitation, which is during the study, the impact energy is gradually changed to identify the exact volume of impact energy required to fill the model reinforced concrete part. Because determining the energy capacity of tested specimens experimentally is challenging, a 3D nonlinear finite element analysis was done using the Abacus program. Next slide is methodology. As you can see, this is the flowchart of finite element simulation analysis using Abacus software. The project began with an analysis of an existing model in order to generate a new design. Next, using the metric assessment method, many sketches were chosen for review and comparison. The matrix evaluation method is a crucial tool for evaluating a project. Basic design was complete using Abacus software. Finite element analysis simulation was performed using Abacus analysis based on the proposed Abacus. Next one is expected result. Based on previous study, impact energy and slab damage have been found to have a strong relationship. Given the difficulties of extracting the slab's load carrying capacities from an impact test, the energy capacity of the slab in overcoming punching shear failure is sought to meet the engineering requirement. As a result, a finite element simulation of the slab impact issue was carried out to numerically investigate the slab's energy capacity under impact load. Lastly, the research plan that have been done by this semester and also planning for next semester. For next semester, I will begin my FYP2 with data analysis. Then go for collecting data, start analysis with Abacus software, and will be continue with validating the result with simulation. After that, I will do the discussion session with my supervisor whether it is acceptable or not. After all have been done, I will start the thesis writing and finally done my FYP with thesis submission. Thank you for lending me your ears. Advice from me, do not forget to take care of yourself and health. Always remember to follow the SOPs no matter where you are. That's all from me. Assalamualaikum and thank you.